Welcome, I'm Bill Wake. We're here working on a program for tune similarity, and lately we've been working on the part that says, let's cluster things and then show how those clusters work. The way we're going to show them is dendograms, and we're kind of working our way through, I guess you'd call it a bit of a spike in some ways, and then some real code on the other side, and just trying to put it all together and make something. So we'll get that together. I don't know. We'll see what happens. All right. Let me just run tests. I haven't done that. I upgraded my Mac today. We'll see if everything's working okay. All right, and I guess we can, let's look at cluster. So I think what we're doing is we're trying to figure out how to make the connections for something. So yeah, this is our test. We've got two elements, 1 and 2. They're both 0 apart from themselves, and then they form a cluster, C1, C2, and we're saying that one is 0.75. So they're fairly similar. And we'd like to do is we want to get connections, and I'm not sure the right word for this, but let me find the picture. Each of these sort of tuning fork shaped things, well, actually just the U part is what I'm calling a connection. And so we need to find basically how long these lines are. And in the cases of clusters, I think we kind of also need to know how tall the whole thing is. So I guess I'm trying to imagine a situation where A and B are close, C and E are close, and the two clusters are close to each other. And so this is more symmetric. And then in that case, I think the line starting here would kind of look mirror imaged and go over here. We need to know the total line, the total distance to start at. And then we would find out, oh, you just draw this one for 2. Okay, whatever the distance is. All right, and because A is doing 8.5, B is doing 8.5, C and E are doing 8.5, say. Okay. Well, okay. We can't do what we got yet, so we'll get to that later. But what we're looking for is if you ask for the connections, there really should only be one U-shaped connector. So the count should be 1. Right now the count's 0, so that's why this is blowing up instead of failing the assertion. But we're saying the top line should be 0.75, the bottom line should be 0.75, and I don't know, I'm kind of making up the distance, but I'm saying 1.5 in height. I'm not really sure what that should be. But I also am kind of convinced we need to know where this line should, how far out the total line should be, so we know where to start drawing. Okay. Now, let's see what we can do to make this pass. And I don't know. Okay, so we're asking a cluster. So somebody's come through and done the distance calculations and all that, and we have this tree is basically defined, as a set of clusters. Now, there's a little difference here that this picture allows these two to be added at the same time, whereas our algorithm that we took from up here only adds one item. So it's not quite a correct picture of what would happen in our terms. But we do expect a cluster here, and a cluster here. And we're going to come in with the top level one and ask, like, how do I draw things? Well, we're going to come in and say, given a top level cluster, I want to produce all the forks. I don't know what we call them. Tines. I don't know. We used to have a thing about forks having 4 prongs and threes having 3 prongs, and we're kind of after torques. Okay. Well, we can certainly make it pass, but what I'd like to do, I could hard code this answer and I don't know. Let's do that. Just go back to our TDD roots. Okay. This. And I will say there is a style in TDD. I don't always use it, but it does work nicely sometimes, where you force in the answer and then you just kind of generalize the pieces to come from somewhere. Okay, so in our case, the cluster. Well, let's add another case. Cluster tests. Okay, so I'm gonna put, this is kind of a more fundamental one. Test element cluster has no connection. Okay, so kind of a base case. I'll just take one cluster, and I want to assert C1.connections should be the empty list. All right. And this test should fail. Okay, because it comes back with something. All right, so I think what we'll do, what is a good way to do this? Well, I want to do something. I want to switch on the self, okay? Because there's two cases, and we've, well, okay, well, we'll just take this, work on it. Okay, this one, break, and this one. Oops. Okay, so the two things that can happen, we can either be an element or a cluster. All right, if we're an element, we're over here on the leaf. We're not drawing any lines. We're just sticking it out. So I don't need any information about it. I just know it's going to return an empty collection. Okay, and then this one. Return that, take out the break. We'll need stuff from it in a moment. Okay. Yeah, that's fine. This should pass. They both should pass now. Okay. Now, connect. Let's see. This should be called connectors. Let's do that. Connectors. Okay. And well, I'll run tests again just to make sure. Yeah. Somebody's not happy. Oh, my rename did not take. Okay, it did. All right. So let's start producing list of connectors. I don't know. It's a little premature, but okay. So now, well, where did top line come from? Now, okay, what I want to do is, this is producing sequence number, level, cluster, and cluster. All right. So sequence number, level, I'm going to say C1 and C2. Hopefully that's reasonable enough. Okay, now I don't think we'll need the sequence number, at least now. All right. The level, though, okay, so we get something that tells us the sort of distance. Again, that's these heights. Okay, we know the height for a given cluster is sitting there right on the cluster, and we know the height of the cluster we're producing, that it contained. Okay, so let's, can't find it in scope. That is weird. I guess I want this out. Okay. Well, let's calculate it. How about my cluster equals, well, it's a connector, and the top line is, well, its height is my level minus C1's level. And the bottom line similarly is my level minus C2 level. And the height, I don't know where we're getting that from at this point. I'm not sure we even need it. We do, but I'm not sure where. All right, now if we added in that line, added in my cluster here, that's perfectly, well, that should still pass, I think. Okay, but a little thinking will reveal that, like, once we get past the first level, this is not adequate. All right, so again, I'll take the picture we got. That's enough to draw this, because this line, the level is 8.5, the level of A is 0, so it'll draw this line and this line. And it has the information to draw those. It has the length of those. Okay. The height, I don't know. I'm not worrying about that one yet. We'll have to, but I don't want to. All right. But what I think we need, I think we need to know the level. Like, where does it start? Maybe we know it from this calculation. All right. But what we don't know is if we're 2 levels deep, right? Like here we just added this, but if we were doing this node, we should add this node that we just generated and, let's say, C. Ignore E for a moment. Add C, and this one's length is, 10.5 minus 0 is 10.5. This one's length is 10.5 minus 8.5 is 2.0. And we should have two things, this one and its children. The C is a leaf, so it doesn't contribute anything, but this one is a real cluster. All right, so let's do that. So we'll have C1, C2. I'm going to make, how about deep cluster? I'm going to let that be C4. Yeah, I wonder if it needs to. Theoretically, they are both going to be the same height in the end. But yeah, maybe it should be storing the level. I feel like it probably should be storing the level, but we'll get back to it. Hey, welcome back. So I don't know if you've been around lately, but we've been doing this stuff on clustering. So we're trying to produce a diagram like this. Given we built something that does the clustering, has the relationships, but now we need a diagram, and so we're trying to get the pieces of information that we're going to need to draw, but there's still sort of domain level stuff. All right, so we're going to create a big cluster. Node 3 is also a leaf, and he's node 3. And then cluster 4 is going to cluster, let's say C1, C2, and C5, 5, and let's make this 0.6, and C4, C3. Okay, so this is a cluster of 1 and 2, and then a cluster with those two plus 3. Okay, and then when we do that, let's see, is this right? I think it's backwards. Let's say this is 90. I think the level is strictly increasing as we had less and less likely nodes till we get to kind of 100%. All right. C4, C3. So this thing should have 2 things in it. And actual 0 is the first cluster. Well, that's the 1, 2, 0.75, 0.75. Yeah, height we're ignoring. And then let's check out this other node. Okay. Top line is, well, I think it's going to be 90 minus 75, so 0.15. And the bottom line is going to be the whole 90 because it was pulling in an extra item. And the height is kind of ignored at this moment. All right. This should fail. We only put 1 cluster in, so 0 is not equal to 2. Okay. So, how about C5? I was expecting 1, not 0. Okay. Connector 0.15. Ooh, interesting. I got a 3/4. Let's take 875. I just don't want to get into worrying about non-decimal stuff. 0.875. Okay. And then the height here is 0.125. Is that right? 875. Yeah. Okay. No. Okay. And we got to feel for the right reasons. So the reason we have is we're just getting the topmost node, which should be 0.125, 0.875. So that one was actually in there. That's what we found, but it's not equal to the one we were expecting because we expected to see the child node in there as well. All right, so all this is kind of a way to get to get this back. I don't know. I've got to flatten these things, and that's just annoying. But I'm gonna get C1's. I have to do C1's connectors and C2's connectors to get a list back. Okay, so because I've got to have everything we already had plus my cluster. Okay, so let C1 connectors equals C1 dot connectors and C2 connectors. So here's the recursion. All right. And that's a list. That's a list. Okay. So we're going to return, well, let's let result. And then I think we'll just do a result.append contents of this result. And then we're going to append new element. Well, that's my cluster. And we'll return result. Whoops. Oh. Var. Okay. Now I think we're kind of ready to think about Max Mudshark's question there. What about the height? Okay, so I think with this, gosh, do I want one more example? Well, I think when we're drawing, we're going to draw these. Well, I don't know that I care about the order too much, but we're going to draw them. So we'll draw 0.75 top line, 0.75 bottom line. I don't know, can I do this without? I'll wave my hand. So here's a U, 0.75. That gets drawn. Then we say, okay, now I'll draw one that's 0.125. Yeah, we don't know where to start. Okay. We want it to start over here in front of the top of the two of them, and then another one that's 0.875 all the way out. But we need that height. Okay, so let's mix that in. A cluster with no connectors, then I guess we don't need to worry about its height. But with these, I guess we want to know. I guess we want to know where to start drawing. Okay, so I'm looking for this number. I happen to know it's 8.5 because these are 8.5 and they're equal. But it's really the level of the child. Well, it's really the level here. And if I draw 0.125 to this one, that's fine. But this should be the 0.875 in our example. Okay, so I think we need to make connector. Well, I don't know. Maybe this height I shouldn't worry about just yet. Let's make that. Maybe that was supposed to be that. I can't remember what I was doing, but it's drawn sideways, so it's a width if it's that. So I'm saying the total width of this cluster, I think that's accurate. Okay. In this case, that's 0.75. In this case, it's 0.875. Well, this one is 0.75, and this one's 0.875. Okay, so when we draw the lines, we're going to take the height, which is really a width. Okay, we're going to take the width and subtract off whichever line we're drawing. So this one 0.75 minus that, we're going to draw nothing extra and only draw the 0.75s. This one 0.875 minus that is 0.75. Sorry, 0.875. I guess we start at 0.875 and we draw for 0.0125. Start at 0.875 and draw for the bottom line. Okay, so let's modify this to take to return width instead of height. I don't think anybody else is doing it but this test. Huh. Okay. Well, width. Okay, and I guess we'll make these work. Okay, so my assumption is the width should really be the level. Okay, because that's how big our node, how far our node is supposed to extend. Okay, so let's cluster, instead of this, let's put our level. All right, and then I think that should do it. Okay, so now well, is it time to start drawing? We don't have this height thing dealt with. Okay, the other thing is, well, okay, let's we calculate connector size. Yeah, max height. The elements just returns the height. Well, the elements, their height is always 0. Get height method that returns the max of the heights of the children. No, I think it's potentially bigger. So let me set up another case, and I don't know if our algorithm can actually produce this case or not. So this one is a balanced cluster, I'm going to call it. No, I think height, well, height is this, they called it delta and they called it level. It was level up here, L whatever. That's saying that's giving you this, I mean, just only paying attention to X. It's giving you this number here, this 10.5 would be the level of the V node. Okay, so V is going to be 10.5 to the edge, to the edge. And then the fact is we don't draw a 10.5 line because we've already got a child there that does 8.5 of it. So we just need to draw 2. This one does need to go all the way across. But yeah, my height is bigger than my children. Well, it's greater or equal to my children. Okay. What I don't know is whether the algorithm will produce this cluster I'm going to draw now. So I got C1 to C2. I'm going to put a C4. I'm going to call them E. Make them elements. E4 is 4, 0.0, and what's that number? Oh, the number is, well, let's make it like 7, 8. These are the numbers that are actually being computed with. So let's say the C4 cluster, well, I'll make it C1. C1 can be number 5, but he's C1, C2 with 0.75. Then cluster 2 is 6. He's also 0.75 because these two are equally close. All right, and he's got, well, C3, C4, and then the balancing one on top is cluster.cluster 7 0.875 C1 C2. Oops, these should be E's. E1 E2 E4 E3. Okay. All right, so I have E1 clustered with E2, E3 clustered with E4, and then I'm putting in C3 is going to connect to both those clusters. And maybe I can make this, well, let's leave it like that. Okay. And so now I expect to find 3 connectors. This one, top line 75, 75, 75. This one should be the same. And this is where the height's being wrong. It's not helping us any. But the last one should be 0.125, 0.125, and 0.875 width. Okay, so 0.125 connects to the 0.75, and those make the whole thing the right width. Okay, and this should pass with where we are. Okay, and then I want to change. Okay, I want to reorganize this slightly. I think the width belongs at the top. Then it's going to be easier to think about. That's the total width, or it's sort of like the starting point, and then the other two. So let's change the tests. And I'm just going to move the width to the front of it. All right, so that shouldn't matter. Width should proceed top line. Missed one. Oh. Okay. All right. So I get max height. Oh, if you're talking actual height, yeah, I'm getting you. I'm getting there. Return the max height of the child, and the elements return the height. Height is not value. See, the problem is these things get reordered when they get matched. So C and E were a lot closer than D was. So the height is really supposed to be like some function of kind of the range it covers. So the height of V is sort of the distance, half the distance of A to E or something like that. I'm gonna switch gears. Let's see, did I check that in? Reorder parameters. Okay. I kind of want to switch gears and go draw something and then come back and deal with the height issue. The height is really the placement, the vertical placement of this line. Of any of them. Okay. We want these lines to be on sort of successive elements, and they should be some relationship to, they should be halfway to the next cluster point or the next item. I don't know if that's all going to be easy or hard, but I'm going to switch back to drawing, I think. But because I have enough information in the connectors, I won't make legitimate pictures because I'll be overlapping everything in one place. But I think I should see line lengths that are correct, and maybe I can do something to. I don't have the count. We saw what a mess that was before. Yeah, we're kind of, well, yeah, it's definitely confusing. Right. They're even saying this is the height, drawn horizontally across the page. It's the height of the tree, or the I guess that's a tree, the cluster. But we're drawing it transposed from that. Maybe I should use the word level even there. Would that be better? The level is 10.5 of this node. It's 8.5 of that one and 14 of that one. Maybe that's better. Okay, let me put a node in here. Draw the cluster nodes. Okay, I don't know. I think what we were doing was calculate the connector sizes, and then the question was, should we call it cluster dot level, not width? Okay, maybe that would help. All right. If I had this picture, well, this is probably the one that's the realistic starting one. If I drew this cluster, I would like them to I would certainly like them to move down the page as they go. I don't know if I can do that. Maybe if I just draw them together, that will be convincing enough. But I just, I don't know. Maybe I'm getting, I don't know. I'm a little lost in the desert in some sense here, because I think I'm getting closer. Those connectors, I think they more or less tell the story. They don't tell the height, the vertical height of the drawing on the page yet. But we've got this for each elements, and then, well, that actually kind of worked. Maybe I can do the same thing here. For each, make an array out of cluster dot connectors dot enumerated, and the id is connector. Is that what these things have? Cluster dot connectors. Well, there is no elements. I don't know if I need to say an id. And we get number and connector in something. All right. And I'm just going to put them out there for now. Well, do I need to do that? Put number in. Well, we got a path. Let's say line. Let's make a line helper. Okay. And the line should be XY to XY, right? Line. Well, connector dot width. That's X. Let's make the Y be 20 times number. So for the width, and then let's draw the Y position. So connector dot width plus top line. And 20 times number. Okay. I guess I'm hoping I get a line for everything. And then where's cluster? Okay, I'm going to make this cluster be something different. Okay. Line is not existing. Okay, so let's make a function. Func line. X1 and X2, Y1 to X2, Y2. And what is the type of this? Is it a view? Let's assume it's a view. Okay, this is connector dot line. This path. Is it not a view? Sure. All right. So we're going to move to X1, Y1. And then we're going to add a line X, X2, Y2. And then from X2, Y2 plus 2. And then back to X1, Y1 plus 2. Okay, well, I'll draw something somewhere. All right. So I'm drawing, well, I got to do it from my perspective, but x1 and y1, draw it to x2, y2, draw it to x2, y2 plus 2, go down a little, and then draw it back to x1, y1 plus 2. That defines a rectangle, and then fill that rectangle, and that should give us a line. All right, now what's your problem here? ID could not be deferred. Oh, he's got to be identifiable. Okay. Well, I guess this is why I want to go back and forth so I can learn what I need. Okay, now what's your problem? Cannot convert int. Okay, fine. I don't want an x2 in there. I saw that go by. No exact method in static expression, built expression. Well, maybe that ID is okay. Let's comment this for a moment. And our cluster, well, these sequence numbers are unique across all these nodes, so they could be our ID. Let's give them that. So cluster connector, sorry, is equatable and identifiable. And then that should complain. Yes, I do. Okay, ID of sequence number. Okay. Well, I guess these are all public fields. Okay, and now anybody who doesn't have an ID is going to be in trouble. Okay, so here it is. And our tests need them too. ID 4, ID 5. I guess that's 5. Okay. All right, where's the line length problem? Yeah, fine. I don't mind spreading that one out because it's kind of the point of the whole thing. All right, test run. Now I should be able to use that in my code here. To ID colon ID. Well, no, they're identifiable, so I don't even need that, I think. Okay, let's make sure. Exact matches generic parameter ID could not be inferred. Why not? So we specify the generic arguments. No exact matches. Reference to static maps that build expression. What if I just return a path and then make you fill it on the outside? Is that gonna do it? Enumerate sequence connector dot element, aka offset element. Oh, I do have to be explicit. Yeah. Is that gonna do it? No. Require connector conform to hashable. Well, I think I get it for saying it. Because these are all simple types. Now I expect lines that I guess they look sort of the right length, but they may be positioned oddly. Okay. That is this cluster. Okay, let's make a new cluster. I really want to take this one I did in the tests. I think we'll take this one. Take that one out. So we have our 1, 2, 3, 4 elements. Sorry, three elements and 2 clusters. This path was interesting before, but I don't think it is so much now. And let's do a fill. Just for variety. Okay, before we had 2 elements with no points. Okay. 1 at 0, 1 at 1. 3 at 2. 1, 2, 3. Where are 4 and 5? Okay. All right. Let's go back. 20 to 300. Well, these widths are not very big. They may be drawing and I just don't see them because they're tiny points. Let's use like 100. I don't know what to call this scale. Oh, why am I being foolish here? Okay. We'll put the scale here. I'll just use that for now. And clearly this should be an X scale. Okay. Come on. That rename is not renaming. Okay. And I think that's because I've got right now they're scaled 0 to 1. This will bring them out a little bit. X scale. X1 is okay. Let's okay. Okay, there's some lines. Not quite what I was hoping for, but so I think what the height is, let's see. All right. The height, what did we do in here? We did it from connector width to adjusted 20 times number. So 0, 1, 2. I thought I'd get 3 lines. 4 lines. Why are you not? I wonder if 20 is just not a great size, but these are all 20 times the y-axis or the index, and it drew the names. I wonder if that's 2 lines laid over top of each other, and that I could believe that's a 0.125, but let's return this, and then I can do some printing. X1, Y1. Okay, I think that'll give us a little debugging information there. There's ways to do this that I don't know very well. But we'll do this. I'm thinking there's some view debugger kind of stuff somewhere that we should be able to do. Okay. 0.75, 0, that's the y coordinate. Maybe we'll add to that to 1.5. Okay. 0.875. Next line, 20 to 1. Okay, that's a shorter line. 0.8.75. Oh, it drew twice. Are there only two? Wait a minute. Okay, for each connector, let's do this 10. 10. Then I'm going to put another one. I only put one line with double. Well, I'm not going to put that one yet. Okay, let's get these two in. Try and get the bottom and the top line. Yeah. All right. Okay. Oh, this is something's going on. These two look the same length. Why there's multiple copies? Okay. All right. So maybe I will try that other line. So that's the two children lines. Probably. Let's do that. Let's just do C4. I'll take the cheap way to get there. That's the wrong button. Okay. Now, that looks like one line, but it's really 4 lines. Why is that 4 lines? There only should be one. Yeah, there should only be one element in our connector table. Unless it's being redrawn for some reason. Sometimes you get that stuff. But this is weird. Where'd the 15? Oh, that's 0. Maybe I should do this like 5 plus 10 times number. Just taking that out to stop a complaint. One's green, one's blue. Is that... Wonder where the green came from. Let's make this one filled. color.red. Yeah, the it's tricky to log those numbers because you you don't really get to draw during the sorry, you can add elements to the output, but you don't get to print or anything like that from there. There is where did I put that? I mean, somebody has produced stuff that would like wrap this in a way that you can call something on it. I don't know if I can do that. Okay, so this is better. So 0.75 to 0, that's at 0, 0.75 to 1.5, 0.755 to 1.55. So that's the two lines across, and then theoretically I have a third line. But they come again. So I don't know why they're being drawn twice still. Can we see something? Well, maybe we could try, like, I don't know, if we're just going to throw the text out there. Does it care? .id. I don't know where it's going to put it, but it'll put it somewhere. Okay. Four. Yeah, we had it centering the other day, didn't we? So I think it's drawing the right cluster. I think it's drawing it twice. Let's see if we can trick it into drawing it twice. Whoops. Oh, man. Well, that would seem to say I fixed it. Oh, wait a minute. That's okay. There's only one cluster. There should be. Well, this is a cluster of 3 elements. So it's C1, C2, and then C4 connects C1 and C2. So it's one U-shaped element. I don't know if I'm Going to count for double CG size. We had an offset somewhere else. Maybe I can say offset XY. So yeah, one connector with, it should be 3 lines. We're only drawing 2 so far. Oh. I'm really not liking these messages. Oh, well, that's fixable. Weird. Cannot convert value of type sum view. Did I leave off a paren? I don't know what I'm doing here. This should be X colon CG float size. That looks redundant. Comma Y colon that. Float parens. That should match. Okay. Simple mechanics. Okay, all that, and I'm not getting anything out of it. I don't know. Maybe I should go dig up that stuff on how to put debugging stuff in. But I'm pretty sure we're just seeing one connector. I don't know if it's... I don't know why it would be redrawing. Yeah, this array should be length 1. Let's try that. Number. That should tell us the highest one that overwrote it, I guess. Which should be 1 or 0. Index 0. Yeah. Okay. All right. So I guess I'm not going to worry about the redrawing at this point. I don't know. I've seen this error. I don't think it's necessarily a real error, but it is suspicious. Yeah, I think it's just getting drawn twice. I may be wrong, and maybe this is a real thing, but I don't know what the cycle would be. All right, so I'm going to take this one out. I'm going to make this well, I'm going to put that third line in. All right. Connector width is the X, and this should be the Y one. And it goes to X again, and then this number should be the Y2. Just to mix them up, make sure we can see everything. All right, I expect my vertical line to get drawn. Oh. Okay. Why didn't you get drawn? 0.7 to 0, 0.70 to 0.75. 0.750 to 0.755. Well, that seems okay. I don't see a green line anywhere though. Connector width. 10 times my number. 0 gives me 0. So I should have a line from 0, 0.750. And the 0.75 would get scaled by x to 100. Okay. 750 to 150. That's the first line. 75 to 150. That's the second line. 155. Yeah, so that's the second line. Then 75 0 to 75 5. Okay, I'm going to make this bigger. I just want to see some effect of it. It should be 150, huh? Sorry, you're saying that this 75 here should be a 150? Because I think 75 0 to 150 0. Right, that's the first line. That's the second line. And then this line I'm trying to draw vertically. So the x stays the same and the y changes, and I would have thought by plenty. Let's see if we can get the line on there. No, if I can see them both. No, not really. Yeah. But I was expecting a green line to show up vertically somewhere. I don't know why not. With extra junk. Yeah. Okay. 75 0. And we're seeing 75 0 to 150. So that line's okay. That's the blue. And then 75 5, it's down. So 0 0 is the top left. And then 75 0 to 75 25. Let's shift it. I don't. Yeah, I mean, I'm hoping for the start positions. I'm just going to try a different number just to kind of force something to draw. It really seems weird to me. Okay, there's a green line. 75 to 80. Okay. $8,000. Oh, okay. Because we're multiplying it. um. So what? Let's go back to connector dot width. So I just want to make sure my line. So it was 75.0 to 75.5. So go from 75. What's my scale? 100. My numbers are 0.75. Okay, so 75 times 100, 0.75 times 100 is 75. Y is 0. So 75, 0. Add a line to one, no, 75, 5. Okay. Then go to, oh, wait a minute. Okay, I gotta run it again. Sorry. Oh. Okay, so there's a blue line and a red line, no green line. All right, but it tried to draw from 75, 0 to 75, 25. So let's check our line method. He goes from 75, 0 to 75, 5. 0 to 5. So that's vertical. Then he goes from there to 75, 7. I don't know if I'm just not working right on vertical lines, but okay, I'm trying to draw a box. It should be easy. X1, Y1 to X2, Y2. 75, 0 to 75, 5. Then X2 is still 75, 7. Nope, 7 further down. And then X1 is 75, Y1 is 2. I don't think I've traced a rectangle with this. I think I've traced a vertical line, so it's just infinitely thin and not doing anything. If I'm sorry, I'm going to draw on paper. I'll show what I do. Okay, so I'm missing one line. I move here. Maybe I am. Maybe I'm not closing my box, huh? I move across. Well, it's not across though, is it? I move from this one to that one. Okay, so 75, 0. And then I go to 75 point 5. Then I go to 75, 7. It's like I need to do, yeah, yeah, you're absolutely right. Okay, but like maybe I need to adjust X's as well. I should go back from, okay, move to there. I go down a little bit. I go back. Uh, Move to the first point. Add a line to the second point. Add a line going down. Move back to the first point down and then move. Okay, let's run it. Well, I like it in principle. I don't know if I'm doing things right with the Y's, but I don't know. I deleted that stuff. No, I didn't. That's where I came from. Okay, I don't know if I can draw it in here, but I think what's happening is I got 75, 0. Let's say that's the starting point. Then I go down to 75, 5. That's that. Well, I only wanted it to be a couple pixels wide, but maybe that's not enough. I mean, the line looks all right drawn horizontally because it's got to fit. It should be a third the size of this vertically, maybe. All right, so I draw 75 to 5, and then 75 to 7, and then I draw, well, that's another star. Then I draw to 75, y1 plus 2 is 2. Right, and then I go from there back to 75, 0. It's still arbitrarily thin. Right, because they're all, I mean, if they were true points, they'd be zero dimensional, right? And they're all in one line with no width. Now this has width vertically. Huh. Maybe I should be adjusting X and Y. All right, it seems asymmetric that I'm only touching Y. I'm only adding this jitter to Y. I guess at most angles, that's going to give me vertical. Yeah, I don't know. I don't think I saw a line. Let's see, it was, I think it's graphics context. Okay. So, okay, I can stroke. Oh, draws a path with context. Okay, let's see what that is. Yeah, I think you're onto onto something there. So if I stroke a path with line width, okay. So then I almost think I don't need the rest of this path. Well, that's the path. Let's see what that does. Yeah, that's a good. Whoops. Okay, that again. That returns a path, so that should be okay. Do I not say? I don't know. Adding that seemed to mess that thing up. No, he's okay. No, he's not. I got yellow complaints, but no reds. So now I do line connector with dot stroke. Oh, maybe I need to do that. Thank you. Okay, so that's pretty reasonable. I mean, other than the length being crazy, because I just made it arbitrarily big. So I should be able to take that out. And that's the 5, so that should connect them. All right, and I guess somewhere the default is green for whatever reason. But I can live with that. All right. That connects those two. Okay, so let's go simplify this thing then. So I think now the path is just that. I'm going to start at one point and then move to the second point, and that should be okay. Now, this 10, well, that height's going to have to change, but that's okay. Okay, this should look right. Oh, apparently not. Now, why it was? Oh, right, you're right. These should all be stroked. Well, I don't think he's a path anymore. Let's see what stroke does. Function stroke. Well, that's not much of a return value. To the context. So it's really context.stroke. Okay, so this is some shape. I don't know if the fill colors will, they may be too late. But I don't really care about the colors. They were just to help me keep them straight. Oh, but they are. Okay. that that width looks a little bigger there. I don't know if I can zoom in somehow. And that line looks fatter than those lines to me. All right, let's clean up a little. Huh. Yeah, I mean it didn't seem to mind the color coming after. So that's it's oh, that all double stroked it. Okay. And then I don't know, is green in this file? Yeah, cover. No. Okay, so I don't know where it got that green. Which I assume is a green. Looks green. All right. This should be normal width on that vertical bar. I'm thinking the font maybe should just be a bigger font and let the pictures be bigger too. Okay. Now, the corners are a little weak, but I think it's acceptable. Let's play with that. Okay, I'm gonna leave this cluster in. It seemed like that's reasonable enough. Well, let's take this out and see what it does. I think it'll just draw lines at kind of randomish places. Not random, but arbitrary. Yeah. Now, the positions are funny. I think we got to reverse them at some point. This looks to me like that gap there. And that should be double to match that, and I think it is. So it's offset there. I've got to reverse XY somewhere in all this mess, but it's closer. I mean, it's doing something. All right, so I will take. All right, let's see what we can do. Choosing our cluster is fine. I don't. Yeah, I'll leave it like that for now. All right, the line width 2. Okay, and then these fills, they're sort of arbitrary. And honestly, I think I can even put them on the array. No. Okay, I won't worry about fills. Okay, well, if these were assembled into the right positions, I think they would make sense. I don't know how much to fight this to do that. The reality is we need a scale on this thing. And the scale's going to look goofy if you only have 4 items, it's going to look goofy if it spreads across the whole screen for that. If you had 40, on the other hand, I think it would be pretty reasonable that it does. So I don't know how much I want to fight that. But connector width. All right, I think I'll get rid of this. Okay. Now this line. I almost want my line function to be the delta. Would that might be nicer. Let's do that. So this is delta x delta y. I'm going to take the print out. I think we can put it back at some point if we need it. Okay. So now X scale, we're going to move to X1 plus delta X, and then Y to Y plus delta Y. I'm just going to make this X. And Y. Try and read more like geometry. Okay. We go to X, Y, and then we move to X plus delta X, Y plus delta Y. And I almost wonder if there's a add line by or something like that. No? Okay, well, I'll live with it like this. Okay, and then these need to be deltas, so take out connector dot width. And this is 0. Take out connector dot width. And double 5 times 10 plus number, that's 0. And this one is width delta is 0. And the delta here is 5. Okay, we'll make sure all this works. Good. That actually looks pretty decent. The corners could be better, but I'm going to take that for this. Work on display, fix line drawing by adding scale and passing delta instead of x2, y2, and draws correct shapes in wrong vertical position. Okay. Well, drawn from left to right. I'll start from a right position, moving left. I don't think it matters. Oh, maybe I see what. Yeah, we need to start. Well, yeah, it probably is better to think of it as coming from here, going this way, and then adding on that much or something. Yeah, that's because these coordinates are increasing. It's sort of telling how far left you want to go from this point. Yeah, I think that's what you're saying too. And if this had started at the same 0 points and overlapped properly, it would look pretty good. I mean, it already looks a little more Dendogram-like. All right. And I think that's sort of the next thing to do to it. Maybe that would be good to do. I think it'd be a step forward. We still haven't dealt with the height and where do you put these things. But if we have the positions right horizontally, that's progress. Okay. I do think we're due for a break. Usually we don't go this long. We'll take 3 or 4 minutes and come back and fix the last thing you mentioned here, this starting from the right. I think also we'll see if we can increase the font size on those text items and make the whole thing a little more viewable and readable. All right, so see you in a few minutes. Okay, welcome back. All right, the font should be the easy one. Okay, we're putting text, position, font. No, is it scale? Oh, weird. Oh, there we go. Okay. Let's do a little. That's not the right way to do it. Sorry. Well, I can do that. Yeah, that's more what I was thinking. Body. I don't know. These headlines, I don't think they promise anything. Like one promises to be X bigger than the other or something, but well, let's just try font dot headline. Yeah, it's not quite the look I'm after. I can use. No, I don't want weight. I guess I want system size. Let's try that. We're trying to get our vertical scale. It's probably easier if we have fonts that do it. Okay, so let's take this out and make it well, maybe it's Y scale. Okay. And then does that give us okay. Text.font. Yeah, that's okay. I could see a little more vertical space between them. I don't know if I'm playing at it wrong, but I'm kind of giving a line spacing there, which there probably exists. Maybe there exists that already on here. Dot line spacing. Okay. All right. Now, somewhere here, position X is proxy size width. So 85% of the way across the page, basically. Y scale. And I don't know that almost. Okay. So I think I can say this times 1.4 should be the distance. Let's pull this out too. I don't know if it'll let me name that the same. Okay. All right. So now I think my vertical distance should be that. Okay, that's the text. Now these lines, let's get them straightened out. Okay, so the top line, delta 0, this should be, yeah, 1.4 is a multiplier. I think that's the way line spacing works. That it's, I better read up. Bottom of one line to the top of the next line. So that should tell me the height. 10 points, but 10-point spacing applied. From the bottom of one line to the top of the next. Oh, well, that's not really what I'm getting, is it? Distance and points. Okay, you're right to call me on it because that's definitely not going to be right. Let's say 10. So I should be able to take the font size plus the line spacing and go by that. And I should see a little more space there now because I had 1.4 before, and now it should be 10. Should be generous. I don't think it looks that generous. Let's make sure what's going on. Nice dramatic number. Has no effect. Okay. What's going on? I think it's how I'm drawing them, right? Position Y scale. I don't think that's doing anything. Because no, it's not doing anything because we're placing a text element with whatever line spacing, and then we come back in and position the next one. So it's not really doing it. Yeah, I think you're right. Maybe we should be multiplying by. Well, I just want to say what the gap is. It's some proportion. Let's take this. Okay, and then nobody should be using line spacing anymore. Because if we had two text items in the same, or two lines in the same thing, that line spacing would kick in. But we have one line of text and then a totally separate text object, so there's no line spacing relationship between them. I'll get there eventually. Okay. That's decent. Okay. This word text at the bottom, we don't need that anymore. Okay. Now, all right, so adjust font size and line spacing. Now, these things, well, if you took the cluster's width or level, I'm going to change that too. Let's get that level thing in. This is level. Okay. I don't know why they're renaming. I did upgrade Xcode today, so maybe I'm paying for it. Okay, so rename cluster connection connector dot width to dot level. All right. Now, let's work out scaling or drawing. All right. I think we want to deal with the scaling. So we know we're in a geometry reader, so we do know the width. And so my position, it's really, I kind of want a scale factor. Every line should be drawn at the same X position. Well, on a connector, right? Yeah. On a given connector. So I'll leave the X scale. Well, I don't know. I think the scaling's in the wrong place, really, here is kind of going to mess things up. But I want to say, so let's just do a run. All right. So like we knew this number was it 75, 150 or something like that. So that's the distance there. I really should take the width minus the level distance, but it should be scaled. Is why I'm going crazy. So if I take the starting point, well, connector.level, that's how long it should be from the width. Minus connector.level, I think. All right, so I'm taking the width, subtract off how far I'm going to draw, and then draw it. All right, and then same thing here. I think it's the same in each of these. Okay. Apparently not. Okay. Proxy size width is 800 minus this level. It's getting way too big when I multiply it. So I'm going to pull the scales out. I'm going to take out these X scales and move them down. Move it right a bit. Actually, I think I need to move them left because this number's not shown up here. But I'm going to take X scale times that. And we'll get these in functions and stuff at some point, but okay, let's see if I can get this approximately right. No, I can't. Okay. Proxy width. Oh, I'm multiplying at the wrong point. You can already see I'm paying for my duplication here to whatever extent it is. X scale times. Okay. Now I think these are, oops, coming in at the wrong level. They're coming in too far to the right, but I think I got to multiply this by my 0.85. Okay. Now, I don't know if those are being... Let's focus on one line first, I guess. Nope. Okay. All right. So if my proxy width is 1,000, yeah, unfortunately, you can't create local variables in the Swift UI part. That's why it's very annoying. But if I take proxy width times 1,000, I'm sorry, let's say it's about 1,000, I think. Yeah, width is 1,000. So 850 minus X scale times connector level. So my level was 0.75, 0.875. So he should start way over there, right? 850 minus 875. Oh, that's totally off the screen. Okay, let's make X scale. If it's 0 to 1, it should be to 1,000, right? Well, it should be to 850. Let's try this. Okay, so my numbers scale 0 through 1 on that middle index, which means they're going to rate 0 to 850. And so if I take the size width 1,000 times 85 is 850, minus 0.85, 850 times 0.85 is going to be 700 or something like that. 850 minus 700, so it's 150. It's going to be over there pretty far, I think. This is the level. Okay, and then the y coordinate is based on these line numbers. And this is a delta. Sorry, y coordinate based on the numbers. The delta is connector dot top line. Well, that's got to be scaled too. Okay, again, I'm just going to look at this top line, see if we can get this approximated. Okay. It's, I don't know what these little blips are. Apply the scale in line instead. Well, I can't hear though, because unless I pull the proxy size in too, in which maybe that'd be right. But this, I can't scale the proxy size, I guess. So I can't just multiply the X by anything. It's got to be, it's scaled up so that it's on the same range as this. So X scale is always, well, let's see, it's 850 is 0.85 of the width of the screen. So that's where that X scale number comes from. Level is always 0 to 1. And so this will be 0 to 850, and minus off this something 850 minus something smaller than 850 is always a little bit over, inside the border. Let me do the same thing across these, because something's still not right though. Is this subtracting? Sorry, should it be subtracted? X scale times connector level double. I do believe it should. X scale top line. So I don't want to increase. Well, I guess I do want to increase. We'll make these consistent anyway. Minus X scale times connector level. Yeah, I mean, I could almost pass the width in as well. Well, yeah, I mean, we definitely need help here. X, Y, X, that's delta 0, delta bottom line. Okay, the top line, X scale times the top line. Again, now top line, I'm messing something up in top line, I think. Double. Level minus C1 level. No, that should all be 0 to 1, 2 then. Okay. All right, let's see what we get when we put all the lines in. And then we'll clean some up. Okay. So 0. Well, okay, something is kind of right. We're missing a line, and I maybe dropped a distance or something. This line, like this stuff, should all be based on the Y scale. And the other way would be, well, okay. Another way would be to like reframe the dimensions and like reverse them, kind of flip it to draw into. But I think this 10 is really trying to be Y scale. Okay, let's pull this out. I'm losing my words here. Y multiplier. Okay, so where's that 1.5? Text, Y multiplier. Okay, I think all these should be based on the Y multiplier as well. 0. Okay. Where's number coming into this? X, Y. Okay, it goes horizontally across. 10 times number. I think this is Y multiplier times Y scale, not number. So 1.5. It's going to be something like that. Yeah, number's the index. I mean, would index be a better name? Unable to type check it because I made it so complicated. Okay. Well, I think, what if I group these? Still not happy. Type check on reasonable time. Okay. All right. Let's make this Y scale. I'm going to try and put this back to font size. Thank you. I can't rename that one. Okay, let's find Y scale. I think he's just so confused he doesn't know what to do. Y scale. Okay. Let's try this. Is really line spacing. Okay, and then I want Y scale of double. And I'll assign that in here. Y scale equals font size times line spacing. Okay. So this goes out. See if that'll build. Ugh. Okay. Well, the group didn't help. Let's make this. I don't know if it'll extract a method. No. Okay. U shape, and it takes something, returns some shape, and the whole thing is grouped. It's going to take screen width of double and connector. Connector, the scale is already defined and it needs the number. Well, numbers int. Okay. And screen width is this. U shape. Screen width, connector, and number. And I'll just comment them for a moment. Make sure this works. Cannot find proxy that is screens width. Which I think does help a little. Group of content to reform to shape. Is it a view? I don't know if it'll cast that for me or not. Nope. No. All right. Okay, cluster. Okay. I'm doing it not far enough. Okay. Well, that got the same result, ugly as it is. Okay. This, he's also got to subtract off connector dot top line. Which is kind of why subtracting is so annoying here. Okay. X scale. Font size is here. You're right. It should be font size. And this should be. What did I call it? Y scale? All right. Okay. Too much. It should be a plus instead of a minus, I think. All right. The fonts look okay. Because I'm subtracting this, so I think I need to add. No. I don't think that's right after all. Yeah, I think eventually we'll do this. I think all that scaling and stuff will go in the line. So the connector dot level, I don't think I should be subtracting this after all. Scale connector dot level is the total width of this cluster down, from the start of this cluster to the end. So I don't think that's right. But okay, let me fix these. I don't understand, and maybe I just go back to printing line. Okay, X scale times the connector level, that gives me a number in 0 to 850. Okay, so 850 minus that number should be the starting point of the whole depth of the thing. The Y scale, I'm going to let be for now. X scale times the top line. So the top line is the number 0 to 1. X scale turns it into something screen sized. Also a fraction, and top line's always going to be no greater than level. Let's go to the next level. This 5 plus 10 thing is not making me happy. Connector bottom line. Okay, let's see where we are. We're running out of time here today. Okay, I think what we're seeing somehow. Okay, I think we're gonna put print statements back in here. Print something DVD, and then we'll return this. Okay, we'll pick up there, but I think we want to see what lines are we actually drawing again, and I'm not sure why this is, why it's, like, why the starting point is wrong. That just feels weird to me. So this starting point could be the one that matches the first two nodes. That would be okay. And then this one, I mean, it sort of looks like it's putting things in the right place, except this is missing a line. So I'm not sure why that's going on either. But you can tell I'm a lot weaker on the graphics than the algorithm side. It feels like it should be so easy. But anyway, I think we've made progress anyway. I mean, I think the pieces are coming out. They're looking kind of right. This, if they were connected differently, like if this were connected up here as well, it would seem to be okay. But I'm just not sure why this is overlapping here. There are lines drawn. That's better than we were a couple days ago. And they look like they would sort of form U's, if they were given free rein. I think maybe we're drawing the lines over each other here. Or maybe this line should be here. And this is the one connecting those two. Like, I almost wonder if there's two lines being drawn at the same Y position here. But we'll see. I mean, we're closer. I think they're getting approximately right scale and stuff like that. And we'll see if we can knock that out tomorrow. All right. So let's see. Tomorrow, same time, 2 to 4:30 p.m. Eastern Time or 6 to 8:30 p.m. UTC. Mudshark, thank you once again for your help, and catch you next time if we can. Bye-bye.